Okay, so we are going to continue our learning of compound inequalities. So we're going to look at a couple examples here. This example here says all real numbers that are at least -3 and at most 5 can represent it in which two ways? So you're going to have to do some problems like this tonight. So when we look at that, what I do is I first write an inequality for each one. So it says all real numbers that are at least -3. So I'm going to take my x, and if it's at least, it's going to be that or more. So that's going to be x is greater than or equal to -3. So that's one of them. So that's my first inequality. Then we have the word and if you remember, and makes them compact form or together. At most 5. So x can be at most 5. So that's going to be less than or equal to 5, right? Because 5 is at most means 5 is the highest. So it has to be 5 or below. Okay? And the word and here tells you it can't be an or problem, one or the other one. And tells you that it is a compound problem and it can be written in compact form. So if you remember, we can take any one of these. I can take x is less than or equal to 5. And then I may take this 3 and move it over here, this -3. And then just remember that my signs need to match. Because I flipped this 3 around to this side, the inequality needs to flip as well. So this would be my compound inequality. And that matches answer choice A. We also have some graphing to choose from here. And remember that says x is greater than or equal to 3 but less than 5. So that would also be this graph here. You can't see it, but that's answer choice C. So this graph and this graph. And just a little hint, when you have a compound inequality like this, it's always going to look like they're connected. Whenever you have an or inequality, they always go apart because it's one or the other. So you might want to try to remember those key things. Okay. This one says, which inequality matches all real numbers greater than -5 but less than 9? So again, I want to take those into two separate problems. All real numbers greater, and that should be than, but anyway, greater than -5. So it just says greater than it, so that does not include -5. So I'm just going to write the greater than -5. Make my x a little bit better there. This isn't turning out so good, sorry. Try a little bit better. So that's this one. But then it says, but less than 9. So again, I'm going to take my x, and it's going to be less than 9. So again, I have greater than -5, but less than 9. Again, these are going to meet. So I can take one of them, x is less than 9. And then I want to include this here, okay? So right now x is on the left. When I write it over here, the x is going to be on the right. So when I put in -5, I'm switching it over to that side, which switches this sign as well, which now makes that from greater than to less than. But remember, we didn't change what it's saying because you always read from the x position. I read this as x is less than 9, which I have here. And I read this as x is greater than -5. I read right to left like this. And so obviously that, let's see, that does not match with that one. That matches with this one right here, right? And that's an or, so that's definitely not it. And this one is correct, I think, right? We said x is greater than -5, and x is less than 9. So that is correct, but it's not written in compact form. So we want to make sure that we write it in this. This is the way that we do that. We put them together. We compact them into one. So I used this. This is right here. And then I took this 5 and moved it onto the other side of the x over here. And when you move it to the other side, it flips this sign around. And again, we read this as x is less than 9. X is greater than -5. You're going to do a little bit of problem solving tomorrow. With compound inequalities like this. And what we do with this is we are going to separate it into two problems. This becomes a problem here, and then this becomes a problem here. So I'll have -6 is less than r minus 3. So we treat that as one problem. I know this writing is terrible and I apologize. Then we're going to take my r minus 3 and make it less than or equal to 17. And so we solve them separately. These two are sharing the middle. So we just solve it like a regular problem. We add 3 here, so that's 0. And then we add 3 here, and that gives you negative 3. And then we have less than and r as one of ours. And then we're going to solve this inequality here. We add the 3 over. So this becomes 0. And we have r is less than or equal to 20. Okay, and then this is nice because 2 r's in the middle, we don't do any switching. So we're going to bring our r's down here, and that's going to be less than or equal to 20. And because my r over here is already on the right side, I don't have to switch anything. I just bring it down here. And you can see that matches with this question right there. So to deal with these is you have to separate them to 2 separate problems. Okay. This one is recognizing a graph, and I'm not sure that we'll get to this today, but just in case. Discounted rates at a theater are available for children 5 and under or adults 5 and over. What was the key word there in that compound inequality? Hopefully you said the word or, and you should recognize ors go in opposite directions. This is an and problem because they're connected. This is an or problem. I don't even know what that is. So obviously it would have to be that one. And it says available for children 5 and under and 15 over. So again, you have your 5 and under and then your 15 over. So you match that to the correct equation. Okay? And then you'll also have these types of problems that you'll solve. And ors get solved separately. So you're just going to solve for b here, solve for b here, and then match it up with the correct graph. So, we may get to that, but I kind of doubt it. So just a couple of key things. Remember, and is where they're connected, or is where they're going in opposite directions. And then on this last problem over here, you need to remember how to use these on each side. And that'll do it. We'll see you tomorrow.